Hi all, Dmitry is here, and welcome to my next video about AA battery testing. Today we will test Yokohama batteries. They are quite uncommon, quite unusual. I found them on the local internet marketplace and they got my attention because we have Japanese name Yokohama, we have on the package Yokohama batteries Japan, we have some address in Japan, we have japanbatteries.eu. So I thought that maybe they are really made in Japan. Because of that I was quite interested and I bought what I can find here available. Let's start with the Yokohama Economy. They are zinc carbons and they have quite unusual packaging. I hope you can see that. We have external packaging and we have shrink foil packaging inside, so they like double packet. And this is quite interesting actually because we have some perforation here, so probably they should open when you press like that, but there are no chances to open them like that because we have that double packaging. So let's open it up. And we have interesting thing, we have barcode here, but when it's packaged you have no chances to see that barcode. Let's check if this barcode match this one, and no, yeah, they are different, there are different barcodes. So it's a quite interesting packaging, I never saw anything like this before. Let's open this and take one out. Come on. Okay. So here we go. And here we see Yokohama batteries, Tokyo, Japan. So we don't have something like made in and country name. We don't have made in EU or made in Japan or maybe made in China. No information about where this battery is made on the battery itself. Let's examine the external package closely, and here we have made in PRC/EU. So yeah, they are made in China, but they mimic to be Japanese ones. Okay, let's test the zinc carbons. Let's go. Here is the raw data for Yokohama Economy zinc carbon battery, and actually for low current 100 milliamps it's quite good graphs. Internal resistance not too high, and capacity above 1000 milliamp hours looks quite good. For 0 to amps it's okay for zinc carbon. And for 0.5 amps, actually, as you can see, voltage drops almost immediately. So for 0.5 amps, I think we can say that this battery cannot handle such currents at all. We're done with testing of zinc carbon one, and now we have 3 different sorts of alkalines. This one is like normal alkaline energy. And here we have energy plus 40% and energy max plus 80% of energy. Please write in the comment what do you think about this. Will this one 80% better than this one, or what that 80% means? As for me, it will be quite unusual, it will be quite interesting and not normal to have plus 80% with this alkaline as baseline, because alkalines can have a difference about 30%, maybe 25%, but not 80%. Okay, let's try them. Let's try this alkaline energy first. Let's try to open it and see if first of all where is made in PRC again. So yeah, it's Chinese. Let's try to open it and see if this is double packaged or not, but I think not, because here we don't have. One moment, please. At the zinc carbons we had this shape plastic cover, and here we don't have it. So I think here we have normal packaging, and we can, yes, we can open and extract batteries easily. Okay, let's check this Yokohama alkaline energy. Here we have graphs for the Yokohama alkaline, and actually it's nothing special here. It's normal graphs for alkaline, maybe except this one, except internal resistance that keeps almost flat profile for the very end, so it's more looks like internal resistance for the rechargeables than one for alkalines, because it's flat, it's not growing while it's charging, so it's not bad actually, and capacity is it's okay for alkalines. But again, it's not some super premium, it's just alkaline energy, so maybe it's okay. Let's take a look at the next samples. Okay, we got data from the normal alkaline energy, and what is remains is some extra grid power or power extreme alkalines. Let's take a look at the energy plus, and it seems like it's also double packets. It's also made in PRC. So let's check the code LR6 BP4FA. LR6 BP4FA. So the product code is exactly the same. But let's check what do we have here. Let's try to open it first. And no chances to open it normally without destroying the package. One moment. And we have also barcode here. It's quite unusual, quite interesting. It looks like somebody bought these batteries with package like this, and then somebody just repacked them with a different package. I don't know why. Let's take a look at the barcodes, and barcodes are different again. Okay, let's test them. Let's test Yokohama Energy Plus. Here we have Yokohama Energy Plus, and capacity is slightly higher than it was for just normal alkaline Yokohama, for 0.1 amp. And internal resistance is more typical for alkalines than it was before, so it's growing slowly and then it spikes up quickly. For 0 to amps it's maybe okay also, but the curve, energy curve, power curve, sorry, it's slightly bent, so this means that battery is not very well handling such loads. But okay, let's take a look at 0.5 amp hours amps, and here we have something unusual, some anomaly. Voltage sucks first and then it kind of recovers. I'm not sure why this happens. Maybe battery is physically warmed up because of internal resistance and current, I'm not sure. But after some time it kind of recovers and then slowly drops. But generally the voltage is at quite low level, at 0.5 amps. And as you can see, the power curve is almost at the same place where we have capacity curve, so it's not quite good for this battery. So looks like Energy Plus is handling loads a bit high loads. Only we hear only about high loads, a bit worse than just alkaline. Okay, let's take a look at the next sample. And finally we have only one batteries remained untested, Yokohama Energy Max plus 80% energy. Best before C battery. So it's again a really strange packaging, and they made in PRC again. So looks like they are pretty same like previous ones, but maybe they are better, more powerful, I don't know. Barcodes are different. Barcodes are different again. It's quite unusual. I never saw something like that before. Let's check them and see what do we have here. Here we have the raw data for Yokohama Energy Max, and it looks similar to what we have with Energy Plus, but we don't have such suck of voltage at the very beginning of 0.5 amps, and voltage generally is quite higher, and we have a bigger difference between voltage and capacity curves. But we have interesting thing here at the internal resistance is growing at first, and then it kinda recovers again for the short time, and then it spikes up when the battery gets depleted. So generally more or less normal curves for the alkalines. Okay, it's time for summary. Here we have capacity comparison, and actually no surprises here, except maybe not too much difference between Yokohama Economy and Yokohama Alkaline Energy. Yokohama Economy has surprisingly good capacity, above 1000 mAh at the low currents. It's really good actually. It's surprisingly well handling such loads. And yes, no surprise here with increased load capacity quickly drops. Interesting that Energy Plus and Energy Max has almost the same characteristics, especially with 0.2 amps. And with 0.5 amps almost the same, but Energy Max is a bit better. Let's take a look at the energy. And when we observe the energy, yes, Energy Max is a bit better, and difference growing with current. So at low current we have almost the same values. At 0.5 amps it's more noticeable difference. Let's take a look at the most interesting part, internal resistance. And here we have surprise. We have internal resistance at Energy Max almost at the same levels like we have with Yokohama Economy. It's quite good from 1250 millivolts, so it's about maybe 40% of capacity. From this moment its internal resistance looks like Yokohama Economy. And surprisingly we have almost the same internal resistance as the alkalines, so it's quite high for alkalines, but the better this alkaline should be, the higher it has internal resistance. So Energy Plus has higher internal resistance than normal energy, and Energy Max has even higher internal resistance comparable to Economy. It's actually quite interesting. I'm not sure why this happens, but my idea is this is because they to get more energy they put less depolarizer there. Because, what is depolarizer? When battery works, battery gives some current. There are some gases, some other substances are formed around the electrodes, and this leads to worse contact between electrodes and electrolyte and growing internal resistance. To counteract this, battery manufacturers add some chemical compounds called depolarizers, and these compounds they should make contact between electrodes and electrolyte better when battery is discharged. And when you add it, you subtract valuable space from the electrolyte and active components. So probably to get maximum capacity, maximum energy, the guys from Yokohama just put less depolarizers there, And because of that, yes, we have maximum energy, we have better energy in Energy Plus than in normal alkaline. But with what price? With internal resistance like that. And if you will compare it to normal alkaline, it will be a worse in every scenario. So why this is important? This is important because yes, Energy Max has better energy than normal alkaline. There are good chances that Energy Max will die in real device faster than alkaline energy, especially in digital device. Probably device will turn itself off just because of greater internal resistance. And no matter than it has more capacity in synthetic tests like that. So as for me, this Energy Max and Energy Plus, they don't have a big difference, big advantage over normal alkaline. And obviously what we saw on the packaging, plus 40, plus 80%, we don't have such difference here. Maybe it's 40-80% about internal resistance at the very end of the discharge, I'm not sure, but it's for sure it's not about energy stored in the batteries. Thank you for watching. I hope you enjoyed, and I hope it was interesting for you. Please let me know in the comments if you want to see some specific tests or tests of some specific batteries. Thank you again. Bye. Okay, here is my thoughts about these Yokohama batteries. Not about this economy or not about some alkalines, but about this brand at all. I think this is a bit unfair because when you at the shop on the round you need batteries, you see Yokohama. Yokohama is associating with Japan, and maybe you will take a look here also and you see Japan batteries EU, Yokohama batteries Japan. So probably you will think that okay, probably not probably these ones should be made in Japan, they should be good, I should buy it even if they are a bit more expensive than local ones or Chinese ones, because it's Japan, probably they have better quality. And probably you will buy them, and only when you will try to extract the batteries you will find that something unusual here. It's not opening as it should. And when you will finally open them, you will find again something unusual, something really strange. And after a time, maybe you will, after a while, maybe you will take a look at the packaging more precisely, more thoroughly, and you will see that made in PRC. You will see that they are Chinese, not Japanese. But probably it will be too late, you already bought them, and they are just normal batteries, nothing special, not super good, not super bad. But I think it's really unfair to mimic as a Japan product, while the product actually is Chinese. So just my opinion, my thoughts about this, you should avoid things like that. Just because it's unfair from the very beginning, from the packaging, it's quite unfair. Thank you for watching, bye.